All right. Thank you for joining us today. This webinar will be recorded. The National Community Action Partnership will post it to our website as well as our YouTube channel. Slides and materials discussed during today's session will be sent to everybody who registered for the webinar by email. This webinar is being held in Zoom meeting mode, not webinar mode, so we encourage everybody to communicate with each other in the chat. And I'll reiterate my request that we all introduce ourselves. We want our network to be on good terms. We will have time for question and answer, and we will have some poll questions as well. Our time is structured so that there is ample time for dialogue. Welcome to the National Community Action Partnerships Webinar Wednesday. I am Amy Jandusa English, Project Director for the Energy Partnerships Project. Next slide. We do want to remind everybody that we have our annual convention coming up August 31st to September 2nd in New York City this year. And after I'm done talking, I will post a link in the chat so that you can access the registration information as well as information about the allowable use of training and technical assistance funds in the weatherization program for attending the annual convention weatherization track. As I said, we have time built in for question and answer, and we're looking forward to some interactive dialogue. But if you do have a question today that doesn't get answered during the session, please feel free to reach out to me by email. I will also post my email in the chat. Next slide. All right. This is one of my favorite parts of all Community Action Partnership webinars. We're going to recite the promise of community action together. You can come off mute and say it with me, or you can just say it to yourself. The promise of community action. Community action changes people's lives, embodies the spirit of hope, improves communities, and makes America a better place to live. We care about the entire community, and we are dedicated to helping people help themselves and each other. Next slide. All right, without further ado, I will turn it over to our main presenters from the Pacific Northwest National Lab.
Thanks, Amy. So I'm Christian from the Pacific Northwest National Lab. And today we're going to be talking about energy-rated storm windows and insulating panels and smart HVAC tools. They're both part of these campaigns that the DOE is running in the residential sector, the storm window and insulating panel campaign, and the smart tools for efficient HVAC performance campaign. Next slide, please. So I'll introduce myself, and I'll have Katie and Allegra introduce themselves as well. Katie, maybe you can start.
Sure. My name is Katie Court. I am a research economist with Pacific Northwest National Laboratory. Been there about 23 years. I also do some program management, and recently have been doing leading quite a bit of field testing, performance validation of advanced window solutions, including storm windows, and that's where I kind of enter in supporting this campaign that we're going to talk about today.
And as I mentioned before, Christian Valoria at the Pacific Northwest National Lab as well. I'm a systems engineer. Background is mostly in commercial HVAC engineering, but now working a lot on these market transformation campaigns, so the STEP and SWIP campaign.
And I'm Allegra Steenson, also with the Pacific Northwest National Lab. I'm a research scientist, and I work on both of these campaigns as well.
Thank you. Next slide, please. All right, so we just have a short agenda today. I'll talk a little bit about these residential technology campaigns that I mentioned. We'll talk first about the storm windows and insulating panels campaign, a little bit about the technology, and kind of applications and weatherization. And then I'll talk about the smart diagnostic tools for quality HVAC installation. Next slide, please. All right, so I do understand that it's a little weird that we're talking about, HVAC tools and storm windows, but I wanted to spend a little bit of time to tie those things together. And really, these are underutilized technologies, is what we're finding. So DOE, they use technology campaigns as a tool to increase adoption of underutilized energy efficiency technologies. In the past, they've done these with in the commercial sector a good amount. So, some of the campaigns that have been run in the past were the advanced rooftop unit campaign. They had the right now they're running the integrated lighting campaign, but that transformed from the interior lighting campaign. Now we're trying to translate that into the residential sector. We found that storm windows are fairly underutilized, but they provide pretty good savings, cost-effective savings. Another underutilized technology are these smart tools that technicians use, and I think there could be an application for weatherization in all of the heat pump and HVAC installs that I've heard that weatherization is doing now. And with that, I think we're going to go to the next slide, and we're going to start with a poll. We're going to talk first about storm windows. So next slide, please. And Amy, if you can launch the first poll. The question here is, have you heard of these modern low-E storm windows, insulating panels, and or other types of secondary glazing before today? Looks like we have almost 70%. Maybe we'll keep it open for a little bit longer. Maybe once we hit 80%, if we hit it, or 75%.
Yeah.
All right, we have 41 out of 56 people. We're at 75%. Let's give 5 more seconds.
Oh, it says 44 of 45 answered, so we'll end it.
Great.
And here's the results.
Thank you so much. So most people here have, know what modern low-E storm windows or insulating panels are. 30% don't, and 7% are not sure. Hopefully, we'll give an overview of the technology. Katie will, and hopefully we'll clear some things up. And can someone let me know if the results actually were shared? Katie, can you see them?
I can see them.
Okay.
Oh, yeah, I can see it.
Yeah, I think all of the attendees could see the poll results on screen. But if you're doing the screen share, you won't be able to see anything except your screen. Just a housekeeping point.
Okay. Thanks, Amy. And with that, I'll pass it on to Katie, who will be talking about the technology.
Okay, thanks, Christian. So it's probably not a big surprise to many of the folks listening that windows are a major source of thermal transfers in the home. But it might be a little bit surprising just how much of a share of windows contribute to your building energy loads. You see here on the bottom right, a graphic that was developed by our colleagues at Berkeley Lab. It's showing a typical IECC code level built home that demonstrates that this home would have about U factors about 0.30 for the windows, which is about R3, and those windows would make up about 7% of the envelope area, but they're responsible for nearly half the heat transfers through that envelope. So a major contributor of both heating and cooling loads. This, of course, represents new home, but this disproportionate contribution occurs in all vintages of homes. So we know if we want to bring down the heating and cooling loads of a home, we have to do something about window performance. Over half the homes in the US are estimated to have what we would consider to be low performance windows. These are single pane or clear glass double pane windows with no thermally improving window attachments. And currently the primary manner in which we retrofit old leaky windows is to replace these windows. But we really only have about 2% of these windows being replaced each year. So we know we have to do something more. You know, one of the big reasons why we don't have more windows being replaced is the cost of window replacement. The upfront cost for a window replacement is just too much for most homeowners. Full window replacement is also a rather disruptive retrofit, and our market research as part of the SWIP campaign suggests that people and programs are not really well informed about some of the more affordable and less invasive window retrofit options, such as the application of modern energy efficient storm windows. So I'm going to be going over some of DOE's research and field testing related to storm windows and insulating panels. And just to be clear, as I get going, I'm going to be talking about interior and exterior storm windows. For some people, the term storm window refers only to an exterior attachment, where the interior attachment would be referred to as an interior window panel or insulating panel, which is why we've titled the campaign in the manner that we have, Storm Window and Insulating Panel. Just to make it clear, we are talking about both interior and exterior attachments. Since storm windows have been around for a very long time, the term storm window, as you might expect, carries some baggage with it. So one of the things that we like to make clear from the get-go is that we are not advocating for anyone to install your grandmother's old homely storm window, shown here on the left, which had to be installed and removed every season, had to be cleaned almost monthly. Storm windows have evolved through the years, and modern storm windows are designed to blend in with existing architecture. They are permanently mounted and are available as fixed and operable models. They're also available with improved glazing performance with low E and sometimes solar control coatings. So the bottom line up front really for these modern thermally efficient storm windows is this is a minimally invasive, easy to install, affordable retrofit that can save about as much energy as a double pane window replacement. And HUD and DOE have thoroughly field tested these modern storm windows and demonstrated that you can achieve these savings, but do it for about a third of the cost or less. These are year-round permanent insulating and air sealing measures that come with added benefits, improving acoustics and comfort. They come as fixed or as operable units, and that operation allows for egress on those windows that you want to maintain egress. You can also see from some of the storm windows I've pictured here is that they are aesthetically pleasing, and they come in different types of configurations. We have pictured here in the top left is an acrylic interior insert, lightweight, easy to install, and then a glass low E insert interior panel just to the right of that. We have a double pane interior inserts as well, and then bottom right you'll see sort of the classic exterior storm window, but you see that these come in multiple colors, and again, it can be an upgrade to the aesthetics of your home as well. So looks like I have some animation here. So just to review, Windows improve performance in 3 different ways. In the field, we've seen significant reductions in air leakage. And so that's one thing that we want to emphasize, especially for weatherization programs, is that this can be an air sealing and insulating measure. Second, you do add that with the second panel, you add that dead air space, which reduces conduction and convective heat losses across that prime window. And then the most recent innovations is that we have the addition of low E glass. Although low E glass windows have been around for a while, it wasn't until relatively recently that the application of that hard pyrolytic low E coating was demonstrated on the storm panels. And so the low E glass reflects that radiant heat back into the home during the winter and out during the cooling season, and just enhances that U factor even more. And then finally, for homes that are in cooling dominated climate zones, there are storm windows available that have solar control coatings that reduce that whole solar heat gain coefficient of the window. Okay, so it looks like we have another poll question. So I think I send it back to you, Amy, and you launch that.
Is everybody seeing the poll? Okay, they're responding, so they must see it. Okay, we're at 100%.
Okay. So
can you see the results, Katie?
I can, and it
Okay.
looks like, I guess one thing that kind of pops out at me is that we have about half that aren't doing really anything with windows. And that is, again, where we really want to highlight some of the strengths of the storm window and some of this affordable options, because we believe that probably a lot of the reason why windows aren't retrofit or looked at is in part because of that high investment cost of window replacement. And so, part of what we're coining here is that, we want to leave no poor performing window behind. We have options here, and storm windows can be a good option to improve that window performance. Here on this slide, next slide, I'm going to be presenting some of the field studies that we have.
We did have a question in the chat, Katie.
Oh,
could
okay, sure.
Could I ask
Yeah.
it out loud?
Yeah, jump in.
Derek Schroeder from DOE asked if you could clarify. Hold on. He just asked, was it stated that that the storm windows can also be an air sealing measure? I think he'd like some clarification on that.
Right, it's just part of the functioning of a storm window is that when you attach it, and I can kind of get into some of the specific ratings that we have for that.
Mm-hmm.
As they'll attach, they provide a sealing measure around that window. So if you had any, certainly you don't want to, if you have big gaps in your window, you want to kind of caulk up that prime window best that you
Mm-hmm.
can. But if you do have some of that leakiness around that window, that storm window is going to add that extra sealing with its in the way that it attaches. And I would, oh, go ahead.
Derek is unmuted. I wonder if he has something he'd like to say about that. My guess is that maybe there's something about the official weatherization definition of an air sealing measure where there's some distinction to be parsed out here. Can you hear us, Derek?
Oh, now can you hear me? Any
yes.
better?
Yeah, we can hear you
I had
now.
to switch microphones. So I just want to one point of clarification note that our program notice 19-5 prohibits window replacement as an air sealing measure. That would also include storm windows. So like the air sealing of storms and the existing window components can certainly be done, but when it comes to replacement, those have to be standalone energy conservation measures and cannot be wrapped into the infiltration measure.
Thank you for that clarification, Derek.
You're welcome.
I'm going to type it into the chat and I'll include a link to that WPN in the follow-up materials.
Okay, thanks. I think I will move on then with some of the field studies. I'm presenting here is a sample of the low-E storm window field studies that DOE sponsored. Note here that I have multifamily, single family, manufactured homes, and we're kind of representing all the major climate zones here. All these homes are representative of what we think would likely fit into a weatherization assistance program, which is another good program fit for this technology. In this Philadelphia multifamily case study, we had 101 apartments that were retrofit with low-E storm windows where they replace old clear glass with these modern low-E storm windows. And as you can see, the energy savings are substantial: 20% heating reduction, 9% cooling reduction, and the whole home air leakage was reduced by an average of 10%. The original low-E storm window field study was completed in partnership with HUD on 6 weatherization homes in Chicago. This is the second picture I'm showing here. This was completed back in 2006 and is shown here in the second picture. The application of low-E storm windows over single pane windows in this HUD home reduced the heating load by 21%, the total home air leakage by 6 to 8%. One other impressive result from this field study is that the field study leads, which is Tom Culp, who is actually on the line and is available to answer questions as well. He had the opportunity to go back 10 years after the original installation of these storm windows and observed that they were all still installed 10 years later, and that there was one window that was maybe left cracked open, which would not be optimal, and one that was maybe cracked for reasons that weren't really the fault of the storm window. So what he observed really was a 98% persistence of energy savings of these storm windows over that 10-year period, which is very impressive. And I point this out because often we find that utility weatherization program managers are resistant to storm windows as they believe that nobody will keep these on permanently. But that's simply not what we're seeing in the field. For the Atlanta study, the homes would be considered low to moderate income. And one finding that I haven't listed here, but I think is really important, is that when the study participants were asked to rate what they liked or didn't like about the storm windows, one of the things that was rated at the very top was the aesthetic improvement that these storm windows provided to their home. And I point this out because so often some of these envelope and weatherization measures are hidden insulating measures. So to have a measure that insulates, air seals, and is considered good looking is, I think, a big plus. And then finally, the field study that we carried out at Pacific Northwest National Laboratory is Lab Homes Test Facility, was twin set of manufactured homes built to reflect thermal features of existing homes. And in this case, we had double pane clear glass windows that we applied storm windows. It's noted we had about 10% annual HVAC savings. In this case, our primary windows were very tight, so we didn't necessarily have that air infiltration reduction that we saw out in the field, but still very substantial savings. So one of the key goals of the SWIP campaigns is to create more program opportunities for storm windows, particularly with regard to utility and weatherization programs. For most of the programs, there are some stringent criteria, as you all know, to getting energy efficient measures and retrofits accepted or recognized as part of the program. For storm windows, we're finding there's some key barriers to program adoption. And one is just simply getting recognition for storm windows, even to be a measure. Storm windows are insulating window panels tend to slip through the cracks somewhere between insulation and window replacement. And as Derek just mentioned, you know, in weatherization, you have storm windows, which we see really as an addition insulating measure in the way that they perform, but they're considered window replacement, but they, you know, it's just not necessarily recognized as window replacement. And so it's just one of those things where it's tough to find a category sometimes. Savings in general do not seem to be very well recognized. And in case I didn't make it really clear, the savings we're seeing out in the field is about 10 to 30% whole home HVAC savings. So big savings. And then there's some barriers we're dealing with about misperceptions about storm windows, everybody kind of having that old storm window in mind. So we're trying to work with utility programs and working through the technical resource manual processes and weatherization audit tools to address some of these barriers, get more acceptance of the storm windows. And then, of course, on the flip side, we're trying to communicate some of these opportunities to folks like you on the phone. So we really see that storm windows are a good fit for both weatherization programs, just in that they can often meet that more stringent savings to investment ratio. Allegra is going to be digging into some of these weatherization software tools and how you would go about modeling storm windows in some of the more common audit tools. And I also wanted to share with you some work that Tom Kolb, who is on the line, as I mentioned, led a modeling study where the savings and costs were simulated in 22 cities across 8 climate zones, where we found that storm windows qualify as a priority weatherization measure in all heating dominated climate zones and most of the mixed and cooling dominated climate zones, because of that relatively low cost and that higher savings that you can achieve. So here I'm just showing an example of output from a weatherization audit tool that shows how the SIR results for the storm windows rank in comparison to other measures in Pennsylvania. You see that storm windows rank just below a water heater tank insulation in terms of SIR, but above attic insulation for Pennsylvania.
And just to interject here, Katie, so these storm windows, these were modeled in Weatherization Assistant. These aren't the default values for storm windows. So we had to do a little bit of, or Tom had to do a little bit of, you know, changing some of the characteristics like U value and solar heat gain coefficient, or I think it might be solar emittance. But yeah, these aren't what comes stock with the program.
And on that note, I was going to turn it over to Allegra to kind of dig a little more into that modeling. She was having some internet issues, so I want to check to make sure she is available.
Yeah, as long as you can hear me.
Yes, we can hear you.
You should be good to go. So earlier this year, we dug in a little bit more into modeling these low east storm windows in both NEAT and MIA, but more MIA, so the Manufactured Home Energy Audit tool for Weatherization Assistant. It's pretty easy to do in NEAT. You just go in and you plug in your U value and your solar heat gain coefficient, which is going to be different for low E versus clear glass. Whereas in MIA, it's a little bit different and it takes a little bit more finessing. But we did a modeling study of climate zones 3 through 7 in 5 different cities, both to get some savings numbers, as well as just get a better understanding of how we can model these windows in MIA, and gain a better understanding of how the program works. Next slide.
Do you see that?
Yes.
Okay.
Okay. So, in working with MIA, we learned a couple of things. So they already have plastic and clear glass storm windows in the setup library, which is a great option. However, they do need a little bit of updating in terms of cost and lifetime values, but that's something that's very easily modified if you're going in and doing an audit. The way we did it was we went in and we went into the setup library and replaced the U values with the U values for the low E storm windows. However, it doesn't have an input for solar heat gain coefficient. So all of our cooling results were not going to be accurate. Heating results, for the most part, accurate, but also some of that solar heat gain is not being captured. So our heating results could be a little bit better. And the lack of cooling results makes it just a little bit difficult without the solar heat gain coefficient. But for just a little sneak peek of sort of the results that we got for our study is we found that the low E storm windows qualify for single pane windows that heat with either propane or electric in zones, climate zones 3 through 7, and then single pane windows in zones 5 through 7, sort of regardless of your heating. And then for double pane windows in climate zones 4 through 7, if you heat with electric or with heat pumps. Next slide. Okay, now I'm going to talk a little bit about some of these energy performance ratings. These are some new resources for homeowners and energy efficiency professionals and programs. We at the SWIP campaign are coordinating our efforts with the recently launched Window Attachment Energy Rating Council, or AERC, which is an independent public interest organization whose mission is to rate, label, and certify the performance of window attachments so that they can provide accurate and credible information to consumers. One of the early market barriers identified for storm windows was the fact that they didn't have an energy performance rating equivalent to like NFRC rating that's available for windows, which can make it hard for some programs to specify high performance products. And to address this, the DOE helped launch AERC, and as of 2020, AERC now has a cool climate energy performance rating and a warm climate rating for storm windows, which is kind of like an apples to apples numeric rating where higher numbers indicate improved energy performance. Here's an excerpt from the database here on the right, where you can look up all of the available storm panels and their ratings and to find out what the AERC rating is, as well as information like U factor, solar heat gain coefficient, visual transmittance, and air leakage. Next slide. Our campaign also partners with the Energy Star program, which has an Energy Star label for residential storm windows. In order to be an Energy Star rated product, the program went through a process to determine that storm windows provided substantial energy savings, that the energy performance could be measured and verified, and that storm windows could be cost effective and the investment could be recouped in a reasonable amount of time. We think that the Energy Star label can help weatherization professionals communicate the value of the product to homeowners since this brand can really provide consumers with some level of comfort in knowing that they are getting top-rated products in terms of energy efficiency. And now I'm going to hand it over to Christian, or a poll question.
Thanks, Allegra. And we can hold on the poll question for a second. I did want to just open it up for maybe one or two questions if anyone has any questions specific to storm windows. And it looks like Sam asked a question. Sam Pardue, what are the DOE's findings on the relative benefit of air sealing versus low E in saving energy? Sam, I'm not sure which findings you're talking about, but maybe Katie or Tom Cole might know.
Well, I would say that our the PNNL Lab Home study is a good measure of the added benefit from low E. In this case, we had, like I said, very tight primary windows, so we weren't actually getting any added benefit from air infiltration reduction. In that case, the combination of both the dead air space and the low E yielded about a 10% HVAC reduction year round, about 12% heating savings and 8% cooling savings. And so we attribute that to that added insulation rather than the air sealing in that case.
Yeah, it'll also depend on the state of the primary window and how well sealed it is. So it'll vary how effective the low E is as compared to the infiltration, but the air infiltration reduction is certainly a benefit of all types of storm windows. And Todd is also mentioning here, a benefit of storm windows that often surprises homeowners is noise reduction. Some storm windows cut exterior noise transmission by 50%. And we are actually finding, we're talking to some partners in New York that's their main selling point, especially in the city. They're adding secondary glazing or storm windows because they have a lot of city noise. So it certainly helps with home comfort, including acoustical considerations. Well, Todd and Sam, really appreciate your questions and comment. And with that, I'll switch over to this HVAC side, but throughout, feel free to ask questions in the chat about storm windows, and some of my colleagues could try to answer them. And we'll also have time for questions at the end. But I do want to make a transition now. So this is for HVAC. I know that, there has been a shift. It seems like we're starting to install more heat pumps now. But this first question, I just kind of want to understand how HVAC systems are installed. Are they typically in-house installations, or are they typically contracted out to mechanical contractors? So Amy, if you can release this poll.
Okay, there we go. I guess while we're waiting, there is a new question in the chat if you'd like to speak to that. It might be a question for DOE actually.
Yeah, that might be a question for DOE. Derek, can you answer that? Or do you mind?
Derek.
Let me know if you can hear me.
Yep, we can hear you, Derek.
Perfect. To not provide a stock federal answer, it depends. So I say it depends. If the grantee is providing the setup and supply libraries and setting the parameters, then it needs to come from the grantee, which would be the state. If the state is having the sub-grantee, which would be the community action agencies, build out their own setup and supply libraries and parameters, which then they will monitor when they complete their monitoring, then it would be up to the community action agency to be able to do so. However, one thing to keep in mind is when the energy audit tool is approved, we're approving the values that have been submitted to DOE for review. So whether that be a measure lifetime, U values, R values, and so on that are associated with it, that's what we're looking at. And DOE does often and does allow for outside of the defaults that are listed in WPN 19-4 to be approved for use, which is, for example, incorporating low E storm windows, to ensure you're getting the proper energy saving details, increased measure lifetimes. If a change is being made to that impacts the savings to investment ratio, then that would need to come to DOE for review and approval, just to make sure that everything was entered correctly. But I hope that answers the question. I never like having to say it depends, but we provide the flexibility to the states to make the determination if they're going to control those metrics or if they're going to push that control down to the sub-grantee level.
And then I guess my question for Betsy Palazzola that asked, what would your preference be? How would you like it to be done in your area? I'm not sure if Betsy can come off mute.
Can you hear me now?
Yeah, thanks.
Sorry, I'm called in from my phone as well.
Oh, okay. What
so
prompted the
I'm
question and what did you have in mind?
So I'm not a direct weatherization provider. I work for a consulting firm that supports some of them. And I think as far as what the preference would be, I mean, on the one hand, if our local agency could do that, it would be much easier, I think, for us to advocate for those changes and sort of run with them. But I think ultimately it's probably better if the entire, and I'm in Michigan, if the entire state of Michigan was doing that right, because it would benefit everybody to be able to be consistent. But we're just, there's also a lot of, in the city of Detroit in particular, which is most of where I work, there are just a tremendous number of home repair type programs going on, and just like at this point, almost triple-digit millions swirling around between home repair and different levels of energy efficiency. And we're really trying to work as an ecosystem to make sure that programs that have more flexibility are able to plug gaps for programs that have less, and to try to bring down this deferral rate issue that we have. So this is a great, I mean, and obviously we have terrible windows everywhere, plus the lead hazard of replacement and all that stuff. So this is a really interesting technology, and I'd like to be able to recommend that our single family home repair programs that aren't beholden to weatherization are also able to take this knowledge and do something with it. But I just don't, like I said, I don't personally work for it, so I don't have some of the nuance already in my knowledge set about how to actually move on some of this locally. And I know there's someone on here, I think, from Allegan County that might be better able to talk about it in Michigan, but that's not necessarily a good use of everyone's time on the call. So thank you.
Well, Betsy,
Okay,
thank you.
Betsy. Sorry to put you on the spot like that, but I do like to
No
hear from the
problem.
audience.
Yeah, and Betsy, I will say that we almost gave Amy a heart attack today because we were not 10 minutes early, and it's because we were getting off the phone with someone from DTE Energy on talking about storm window pilots. So it might make sense for us to connect at some point in time, just to get your thoughts and see if there are any synchronizations or collaborations that we can do.
Very cool.
Yeah,
For that, thank you.
Michigan and Detroit in particular are definitely a hotbed of all sorts of activity. We have the poll still open, and we only have 42 of 57 participants answering it. So I'm wondering if anyone, should we go ahead and close it, or is there any particular reason why folks do not feel like they can answer this question at all?
I think we can close it, and if anyone has any more questions, we can put it in the chat. But yeah, this is actually pretty interesting. So it looks like maybe 6 agencies or 6 people representing organizations have in-house installations, but mostly everything's contracted out. Or, there are 6 also responses where you don't install or service HVAC systems. So that's really just interesting information. But it does look like the majority of agencies here, at least, do either install HVAC systems or contract out that work. Next slide, please. Uh-oh. Kitty, we're not seeing the presenter mode anymore. We're just seeing, yeah.
Okay, what are you seeing? And with the poll question and a second poll question, does that?
We're
okay.
seeing your screen, but it's not in slideshow mode. So we're seeing your PowerPoint, but it's back at the beginning.
Oh my, okay. Let me see.
Sure. Bear with us, folks. We still have time.
Okay, I'm gonna stop sharing and then try to share again.
While you do that, Katie, if you'd like, I can launch the next poll question so that our attendees have something to keep them busy.
Yeah, that'd be great.
Okay, moving on to poll question number 4. It might be a little bit premature. What types of HVAC systems do you install? Okay, Katie, while folks are answering that, we do see rated efficiencies don't tell the whole story. So is that the right slide, or do you need to back up?
I think we need to back up.
But we're on the right track.
Okay, good. You see actually the whole thing, not just.
Yeah.
Okay.
It's in slideshow mode, and now it's on poll question 4. So I think we're in good shape.
Okay.
And I'll just give everyone a few more minutes on this one. It looks like we have a little bit over 50% participation.
Yeah, not everybody on the call is with a weatherization agency. I think that was highlighted by the person who spoke out last time. So that might be why we're not getting 100% response rate, and that's probably okay.
Okay, that's fine. And it looks like it's almost an even split between heat pumps and furnaces. I forgot, Alan, I forgot to add that option. Sorry about that. All right, actually, this is multiple choice, so you could have selected all of them if you wanted to.
Yeah, you should be able to select all of them if you'd like. Okay, I'm going to go ahead and end the poll.
All right, great. Thank you, everyone, for responding to that. Yeah, I just wanted to get a good picture of the types of systems that everyone's installing. I know that there's kind of this big push for heat pumps across the states. And I think there's a lot of things that we need to consider when installing heat pumps or any other HVAC system. But right now I want to talk a little bit about the efficiency of HVAC systems over the years. As you all probably know, we try to increase the minimum performance ratings through codes. So as you can see here, this is a figure from EIA, just showing over the years how both the cooling efficiency and heating efficiency have increasingly gotten better since they started enacting these types of codes. And there are, a good amount of premium high efficiency HVAC units that perform much better than the code minimum. I think this last year's Energy Star top rated heat pump performed at like a 28 SEER or something like that. So like the code driven minimums are certainly at the bottom of the spectrum. Like you have to install those, but there are very high efficiency HVAC systems now. And I think as was shown by the poll, heat pumps are kind of growing in popularity. Being able to take advantage of the reverse cycle heating to provide electric heating is a big push. Next slide, please, Katie. And just because a unit is rated at a high efficiency, that doesn't mean that that's what's being actually seen in the field. So improper installation of these different types of systems, specifically central air conditioners and air source heat pumps, result in decreased performance, energy waste, and reliability concerns. So a recent literature review from the DOE found that there was at least one energy wasting fault in 70 to 90% of systems in homes across the US. And a recent NREL study found that compared to the no fault baseline, these systems that are improperly installed waste 9% of energy across the US. So that's a big problem, especially if we're talking about, installing HVAC systems and heat pumps as part of, our weatherization efforts. We don't want to increase the energy burden for our clients. So on the right here, this is really just an illustration, but it kind of shows that these different things that may be wrong with the system, the installation and design. So the sizing, the installation aspects like proper refrigerant charge, correct airflow, and making sure that the ducts are correctly sized and sealed. Those all affect how the system actually performs in the field. So just because you have a high rated efficiency doesn't mean that you have it doesn't mean that efficiency is realized in the field. Now, this campaign is trying to increase the use of smart diagnostic tools that help bring up the efficiency in field and performance and optimize the performance of HVAC systems. But first, to talk about the smart diagnostic tools, I want to talk about kind of the traditional diagnostic tools. I know that some of the folks here have in-house installers. Some of the folks, or most of the folks here, actually contract this work out. So, it'd be interesting to see, if the contractors that you're working with use these analog tools, these analog gauges, and these traditional tools. And, I just like to show this picture as, this might be what you're used to seeing is a technician or installer out with maybe a charging table, maybe a PT chart. They have their multimeter and their analog gauges. They end up hooking up these gauges that have long hoses on them that release refrigerant and can introduce non-condensables into the system that also decrease the efficiency. And I want to juxtapose this picture with the next slide, if Katie can. Thank you. So you saw the picture of the traditional diagnostic tools. Now I want to show you a picture of the smart diagnostic tools. Katie, you advanced it one slide too far. Thank you. So, what these smart diagnostic tools really are, they're, these probes and sensors and gauges that are digital that wirelessly transmit to a diagnostic application. Now, this diagnostic application provides automated fault detection diagnostics. It helps the technician by suggesting corrective action. It runs performance calculations, ensuring that, when you're installing, you have proper refrigerant charge, you have proper airflow, there aren't any other faults with the system, which is really important. I think, we saw earlier that 70 to 90% of homes have an energy wasting fault that ends up, with poor comfort for your homeowners or renters and higher utility bills. So we want to make sure that these systems are operating as optimally as possible. So these smart diagnostic tools are really the way that the industry is growing. And I think that there are some, applications for weatherization, whether it be, if you're an in-house, or if you do all of your installs in-house or some of your installers in-house, maybe you can use these tools to be able to properly commission your systems. And if you don't, maybe you can use these tools to non-invasively test the systems that your contractors or subcontractors are installing to make sure that they're performing well and doing a service to your clients. Next slide, please. So with that, I do want to ask another question, and this, I don't know if we created a poll for this, but you can answer it in chat. You can talk a little bit, but how do you ensure quality installations on your HVAC system installs?
Are you guys seeing the poll?
I don't,
Am I frozen?
no, you're not frozen. I don't think they're are seeing a poll though. Is there a poll for this one, Christian?
No, I eventually, yeah, poll question 5.
Oh,
How do you
there, yep.
ensure-
I'm seeing it now.
Okay. I
Okay.
got an error that said failed to launch, so I relaunched it.
And it's fine. This is really just to kind of spark up some conversation.
If there's anybody that wants to come off mute and just talk about it, we can have dialogue. Maybe use the raise hand function. We'll try to scan the room.
Yeah, and I did see that Tommy Kellogg mentioned that I know we have a QCI done on everyone installed. So if you're willing to talk a little bit about that, I'd like to hear about it. But if not, then that's totally fine too. I have some more things to talk about.
Yeah, I can talk a little bit about it. And I'm Tommy Kellogg. I work with Habitat for Humanity, actually, in Omaha. So all of our installs for HVAC is currently contracted out to contractors in the city, the county. So we actually go out and do for especially with the emergency repair, a replacement, we have to have a QCI done. So we have some BPI certified QCI people in our in-house team. So they go do some diagnostic testing on it. We also, I'm sure like everyone else, probably we have typically we are required to put in 90% or better on install, or we do at least. And I can't remember we try to shoot for a higher number usually so we can meet that qualification as well. But yeah, we also have an inspection done on the existing HVAC as well before we even do anything else as well. So that's a little bit of it. I'm sure it's probably somewhat similar in a lot of areas, but it's kind of how we tackle it.
Okay. Well, thank you for that answer.
Yeah.
Yeah, it's what I've been seeing is that a lot of, or at least what I've been hearing from some other weatherization agencies is the most that they're doing is a more or less a visual inspection. Then maybe they have some checklists, but these tools enable kind of more so evidence-based or data-backed quality installations. So you're able to actually see like a checklist that is and here I can talk about this too, Katie. You forwarded it, but a lot of the quality installations that we've seen and programs that we've seen done, they've been done through this manual data entry that ends up being pretty time consuming for contractors. So they don't like to participate in these types of programs. So it could either be written down on a piece of paper and then entered in online into a PDF, or directly entered into a PDF. But this is kind of the older way of doing things, and with these tools, there's a little bit of an improved way of doing that. Katie, next slide, please. So now you get these, with these tools, they connect to these apps, and you're able to get, things like system scores. You're able to really verify with data and actual measurements from the system that your system is performing well, or as best as it can, with the constraints that you have. So it's less of a rule of thumb now, and it's more of or visual inspection, and it's more of an evidence-based, data-backed inspection. Next slide, please. And I do want to note that, these tools that I talk about, they're not, they don't solve the whole picture of quality installation. There's a lot of training that still needs to be done on heat pumps specifically. And there are, standards out there, like, the ones that ACA puts out, the Manual J, SD, QI5, that all help with, the full picture of quality installation. So sizing, selection, design, and installation. But these tools help with installation commissioning and also with some maintenance. I like to say that, for the Manual J, you don't do actual hand calcs for that. You use the software to help do the Manual J. These tools help with, QI5, making sure that the system is commissioned well. I do see a question in the chat from Alan. How long would it take to do an evidence-based QI? So we're actually just out with one of the weatherization, or two of the weatherization agencies out here in Colorado. And we did a demonstration on these tools. And, we're doing a lot of learning while we were doing it too. We were out there for 2 hours, but really the process should take no more than an hour. You have to wait for the system to stabilize. I think it'll typically take 15 minutes. But, just putting the sensors on, putting the probes on, running the app, it should take, no more than an hour. Next slide, please. So this is just a quick slide on the campaign that we're running and why we're running it. Improper installation or maintenance is a common issue. A lot of times we just don't know it because we don't have the tools to show us that we're installing systems wrong. So a lot of contractors that start using the tools, they actually are kind of eye-opening to them. Like, why am I getting a bad grade on this system that I thought I did perfect on? Why am I getting a B on it? Why am I getting a C grade on it? So the tools are eye-opening, and they're also a learning experience. There's a lot of information embedded in the tools that would help contractors learn. So far, we've developed some different things, like a contractor case study, a case study on a utility program. We've partnered with the Arkansas HVAC-R. Katie, stop screen sharing.
Didn't mean to, but I will. I'm not sure. I will try again. Can you see it?
We're seeing the wrong side. We're seeing the next slide. The presenter's view. So if you switch screens or go to display settings, maybe.
I'm gonna. Okay. I'm gonna stop share and try again. Okay.
No worries. I've had that happen with a presenter one other time, where you get that black screen with like 3 different slides. And I can't figure out why that happens sometimes. So you're in good company.
There you go.
Yeah.
So So these are just pictures from the demonstration that we did yesterday. We're out here in Colorado with the Energy Resources Center and with Housing Resources of Western Colorado to do a demonstration of these tools. As you can see, the tool setup's pretty small. You can bring it in a bag, and you don't have to lug around big manifold gauges anymore. And it's all, it all streams to this app. They're trying the tools out, and really we're trying to see what the best practices and lessons learned for implementing these tools within weatherization, heat pump installs, other types of HVAC installs, what that actually looks like. And we want to be able to share with other agencies like how these tools can be used. So it's still certainly a learning process, and I'm excited to see what they end up doing with the tools and any information that we can share. But if you're interested in something like this, if you do in-house installs, or even if you do installs, or if you sub out installs, there are non-invasive ways to test a system where you're not actually hooking up to test for pressures. You're not hooking up your pressure probes and not breaking open the refrigerant cycle. That do tell a little bit about the system and is able to provide some fault detection as well. And I don't know if it's able to give a system grade, but I think it might be. But if you're interested in doing something like this, please just talk to me, and we can try to schedule something. Yeah, just let me know. Next slide, please. And this is our call to action. So, with the campaigns, to kind of prove our worth, we need to have partners that are interested in the things that we're doing, and to make sure that if people are actually interested in the technologies. So, if you join, you can stay up to date with the latest news of the campaigns, learn about best practices. We can facilitate connections with manufacturers. We've heard that some people may have difficulty getting storm windows. I think we have some manufacturers on the line too for storm windows that could answer your questions right now. We also, can connect you with some experts for technical assistance. And we're also interested in running any sort of pilot program. We have the web pages here listed on the right if you want to check them out, or you can just contact me or our generic tech challenge at pnnl.gov email directly. I do see Alan mentioned that you're interested. If you want to send me your email, or just shoot an email to me, then let's do that. And I think that this might be it for our slides, Katie. Is that correct?
Yes.
All right.
All right. Well, thank you to all of our presenters from Pacific Northwest National Lab. That was incredibly dense technical content. I'm not going to lie, I couldn't follow all of the details. I was delighted to see so many of our weatherization experts participating in the conversation and asking so many good, detailed questions. I hope, somebody's trying to get in from the waiting room. I hope that everybody found the information useful, and will circulate the slides and the link to the recording when we send it out by email. Feel free to share it with your colleagues. Feel free to reach out to our presenters at the email addresses that they shared. I'll put that in the email that we send out afterwards as well. And I look forward to continuing this conversation about these two new exciting technologies. Any closing remarks from our presenters or any of our attendees?
We're also happy to stay on the line to answer any questions if there are any. Like I mentioned, we do have a few manufacturers on the line, some of the storm window and insulating panel manufacturers. So this is your chance to ask them any questions. I think we have, I think Larson and Indo Window may be on the line still.
I think I have had feedback from weatherization folks in the past that the insulating panels were not available in their area. I remember when we did a newsletter article on the SWIP campaign, I got feedback from someone saying, we used to use these in one location, but they're not available now that I'm in this state. So is this a technology that's widely available, or is it something that is hampered by supply chain concerns, or how does that work?
So
Well,
I work with Indo. We're an insulating panel. We were hit by some supply chain problems, but we are up and running full force, all 50 states and Canada.
Mm-hmm. I also thought there was an interesting comment midway through about the fact that the insulating panels can reduce sound pollution from the outside, and that was especially important in big cities. I think that poster mentioned New York City. And that got me thinking about noise pollution and the impacts on human health. And I know that that's something that is gaining consideration. So the idea that you could block airflow and block sound flow is not lost on me. I'm physically located in Chicago, and we have 2 major airports where sound, like exterior sound concerns are a big deal. We know that many of our low-income folks live near noisy transportation, highways and airports and factories. So I think that's an interesting angle that I'd like to hear more about in the future.
Yeah, the healthy homes is something we're really involved with, not only with noise and sound pollution because it is so detrimental to human health, but also indoor air quality, because a lot of LMI communities do have high air pollution in their areas, and sealing out that polluted air really helps them have a healthier home. But then, yeah, noise pollution, I would say about 50% of the business we do to ratepayers is typically for noise reduction.
Okay. And I would think that noise concerns are probably closely correlated with air quality concerns, right? Like if you have a homeowner that's complaining of indoor noise pollution, they probably have other types of pollution as well.
Exactly. And especially here on the West Coast, we have a lot of wildfire seasons. The smoke from those wildfires are really hurting people, especially with asthma or other underlying health conditions. And just giving them a healthier home has really helped.
And I would just add, Amy, that we just recently, we're trying to add the acoustic measurements to some of our more recent field studies because of the increased recognition of that as being, definitely beneficial and having sort of the health and well-being. And we just did on a single family home, the addition of an interior storm windows. These were the Larson interior, and we saw an measured 8 decibel improvement, which is kind of roughly by the sound and people who research sound is kind of like reducing the noise by half in yeah, so very substantial.
And as far as I know, there isn't any kind of sound consideration in the weatherization program, but I believe that it is something that comes up in some healthy homes research, right? Yeah. So probably an interesting new direction in the future. Yeah, it's up to 70% of noise is what Sam Pardue is saying. Great, well, thanks. Oh, go ahead.
Oh, sorry, I was gonna say, it looks like Robert has a question. What is the general cost per United inch of these improved storm windows? I think since we have a couple of manufacturers on the line, maybe I could talk to you about that offline. So I can send you an email if you want to talk about that.
Yeah. Well, thank you to all of our participants today for all of your enthusiastic questions and comments in the chat. I look forward to bringing more content in the future around this topic. I can see that it's of great interest. I know that we raised some questions about how best to model the interior storm windows within the weatherization program, like whether or not it could count as an air sealing measure. But I'm also interested in knowing if any of our participants might use this technology with non-DOE funds, because it sounds like there may be some constraints with using the DOE funds, but these could be something that you might be able to incorporate into your jobs with non-DOE funds. So if anyone has thoughts on that, post those in the chat as well. And hopefully we'll get an update from our friends at PNNL on this project again in the future.
Yeah, well, thank you, everyone. And Amy, thank you so much for having us and for hosting.
Thank you. Take care, everybody.
Thanks, everyone.